We just talked about, is there anybody there? Nope. Okay, so let's go ahead and, so skeletal muscle fibers shorten as thin filaments slide and are pulled to the center of the sarcomere. The depolarization of the entry of sodium causes calcium to release by the sarcoplasmic reticulum, and this is the release of calcium causes calcium to bind to troponin and to be exposed to the actin, which pulls the pulls the actin into the center of the sarcomere. Okay, a lot of stuff happening. I'll go through these, and there's a lot of videos on that I have in the blackboard. Okay, so muscles develop tension. That's all they do. They generate a pulling force on tendons, and a brief contraction is called a muscle twitch. So if we have a twitch, which indicates the amount of force, and over time, you can see that the muscle contracts very quickly in about 15 milliseconds. A latent period where the muscle has to be, it's at rest and it has to be stimulated by the acetylcholine to allow the sodium to move into the muscle fiber. So this is a twitch, and as the actin slides to the middle of the sarcomere, we have contraction. Okay, so there are different types of muscle contraction. The green arrows represent contractions, and you can see that you have a summing process. And the closer that the stimulus is, the muscle can increase the force. And if it's not totally contracted maximum force, it's called incomplete tetanus. Complete tetanus is when the stimulation of the muscle causes the muscle fibers in a muscle to completely contract, and you have maximum force generated. So incomplete tetanus when you have partial contraction and relaxation, and then complete tetanus is when you have the frequency of stimulation close enough so that there's no relaxation, there's only generation of force or tension. Okay, so if you look at a muscle, there are multiple nerves from the spinal cord that go to all of your muscles, all of your involuntary skeletal muscle. All the fibers have to be connected to nerves because they only contract when they're stimulated. So motor units are the muscle fibers that are connected to one nerve with multiple extensions. So if you look at your eye muscles, you may have one nerve connected to a very small number of muscle fibers. If you look at your thigh, you're going to have motor nerves connected to a large collection. So that's a motor unit. So the number of muscle fibers connected to a nerve is a motor unit. That allows us to control fine movement and very aggressive total movement of a large muscle. So part of the way that you control the strength of contraction is the motor units that are connected, which means certain fibers are connected to certain nerves, and the number of fibers that can be connected or can vary. Okay, all voluntary movements depend upon the frequency of the action potentials and the number of motor units that are recruited. So we have here, again, a muscle has nerves coming to it. A motor unit is the number of muscle fibers that are stimulated by one particular nerve. So the frequency of the impulses plus the number of motor units involved is going to control the strength of contraction, the force of contraction. So we're not going to worry about this. Okay, muscles can only pull, they don't push. Muscles elongate passively. They contract by the ATP, which is causing the myosin heads to pull the actin into the center of the sarcomere. So we said that ATP and creatine phosphate. So the ATP energizes the myosin head. So contraction has to have ATP. A bridge is formed between the myosin head with the calcium exposing the binding sites for the myosin head on the actin. Creatine phosphate is another source of energy that is used by muscles to contribute to the total contraction of muscles. So the mitochondria is going to make ATP. It's going to take glucose, and the energy of glucose will generate ATP, and creatine phosphate will be generated. Any glucose not used is going to be stored in the liver as glycogen or animal starch. So we said that muscles are cells, they have mitochondria, they use biochemical processes to generate ATP because there's no muscle contraction without the energy of ATP. So ATP is formed by phosphate and the energy from breaking down glucose. It's all I expect you to know. We're not going to get into pyruvic acid. What you should know is that the energy for skeletal muscle contraction and all muscle contraction is a result of the energy produced by the food you eat from fatty acids, glucose, and so on. Okay? So the bottom line is that glucose, fatty acids, lactic acid are going to produce ATP. That ATP is going to be used to energize the myosin head, which binds to the myosin binding sites on the actin, and that's going to cause contraction. Muscles obviously get tired when they lose and run out of ATP. They have to recover, and they have to wait for oxygen levels to go up. So muscles take time. Everybody knows that muscles can lose their ability to contract, and it takes a little while to get more ATP and more oxygen to restore the contractility of the muscles. Okay, so skeletal muscles metabolize glycogen, metabolize glucose, and store glycogen. Okay, aerobic breakdown is when the oxygen is needed. If you run out of oxygen, you can do anaerobic, and you can have lactic acid help generate ATP. Okay, we'll let somebody else in. Okay, so there are two types of skeletal muscle. Just know fast fibers and slow fibers. And we're not going to worry about this. If you don't use muscles, they become inactive and they weaken. So cardiac muscle. Let's stop there. Let's go back to the here and stop recording for a moment. Okay, stop.